Today on the Beyond the Garden Basics podcast, we're talking mycorrhizae. No, don't go away. Don't go away, please. Just listen for a minute or two, would you? Mycorrhizae is the reason you have successful plants. Mycorrhizae, if we didn't have mycorrhizae, you wouldn't have a garden. So how can you make more mycorrhizae? Well, you can. You don't have to buy it. We'll tell you how. Pat Rosales is with us, Master Gardener, Sacramento County, who wrote an excellent article for the Sacramento Master Gardener newsletter in April, all about packaged mycorrhizae. Now, I think we have to establish something right off the bat. A lot of people think mycorrhizae are critters, but no, Mike and Cora don't live in your soil. It is a relationship that's called a mycorrhizal relationship, and it's because it's a mycorrhizal relationship is the reason a lot of these fungi, these various funguses, if you will, are called mycorrhizae because they're involved in a mycorrhizal relationship. It's basically a two-way street between the roots of your plant and the fungi in your soil taking care of each other, which makes your garden thrive. But there are things you could do to it that could destroy it. There are things you may not be even aware of, and you may not even realize you don't have any mycorrhizae. There are certain conditions where you need to have some mycorrhizal relationships going on where none existed before, and we'll tell you how. It's mycorrhizae today on the Beyond the Garden Basics podcast. And by the way, if you think this is daunting, stick around for part 2 of today's podcast, where we talk to Jeff Lowenfels, the author of several books about soil microbes. He has a book called Teeming with Microbes, Teeming with Fungi, Teeming with Bacteria, Teeming with Nutrients. Well, you get the idea. And Jeff will really give you the lowdown and delve deep into the science of mycorrhizal relationships and why they're so important in your garden. Pat Rosales, French horn musician and master gardener. Pleasure to have you with us again to talk
Thank you.
mycorrhizae. And a lot of people think that, okay, I've heard about the benefits of mycorrhizal relationships and mycorrhizae now for most of the 21st century. I guess I'll go buy me some. Well, before you do that, let's talk about exactly what they are and what they do, Pat. What are they? What do they do?
Well, mycorrhizae are collectively the mycelium of the fungus that lives in our soil. And they develop this, as you said, a very symbiotic relationship with your plants. And so the plants produce a carbohydrate because they photosynthesize from the sun. And they produce this carbohydrate, which they exude at the root tip. The mycorrhizae come along and they live near the root tip. They use the carbon from the plant as nutrients. In exchange, the mycorrhizae provide nutrients, make nutrients available to the plant that they otherwise wouldn't be able to use.
It sounds like a fair exchange to me.
Yep.
One of the big ingredients that the mycorrhizal relationship can provide to the plant is phosphorus. And this is where a lot of gardeners might go askew, because if you add your own phosphorus fertilizer, you inhibit the mycorrhizae, the fungus that are in there. And it's not so much it doesn't necessarily kill the fungi, but it sidelines it because the plant says, hey, I've got all this fertilizer falling down as little blue powder. I'll use that instead. You go play with yourself or something. Just leave us alone. And the poor mycorrhizae basically just have nothing to do, so they do not thrive.
And the plant can't really use the phosphorus in that form.
That's right. Somebody has to change it to something that they can use.
That's exactly what the mycorrhizae do. They make the phosphorus available to the plant.
And that's soluble phosphorus that we're talking about. When you apply phosphorus via a fertilizer, that's usually soluble phosphorus. And that, again, sidelines the mycorrhizae. Mycorrhizae, though, are very good at using insoluble phosphorus and converting that to something that the plant can use. This is one of the reasons why mycorrhizae are so popular in agriculture. It's cutting fertilizer costs for agriculture for those who are farming organically or farming sustainably or just want to cut their fertilizer costs, by having a thriving soil with mycorrhizal relationships going on, there's all the phosphorus you need so those ships can just keep circling in circles and in the Strait of Hormuz, and your plants will just be as happy as ever.
So there are things that you can do. For example, if you rototill periodically or dig to any depth, what you're doing is disturbing the soil and destroying the mycelium. So every time you do that, it has to build itself up again from scratch. So that's detrimental. Another thing you can do is to create pathways so that you're not compacting the soil, because the mycelium that contain the mycorrhizae can't live in a compact soil. And also avoid chemical fertilizers and herbicides because they both kill mycorrhizae. And something we don't think about a lot is to have something growing in your garden, even during the off season. For example, you might have one plot where you planted tomatoes and you pulled up the tomatoes and you just want to leave that fallow until the next season. And your mycorrhizae need the nourishment that comes from the roots of plants. And so if the tomatoes are gone, plant something else in its stead, something over the winter that can nourish the mycorrhizae.
Sure, you can put it in cover crops, and you can also, instead of yanking out that tomato plant, just cut it off at the base of the soil and let the roots remain in the soil to help the mycorrhizae thrive during the winter.
Absolutely.
So there's a lot of ways that you can encourage mycorrhizal activity without too much work on your part. Cover crops are a great idea. It works well. Mulch, too. If you're using an organic mulch, be it compost or leaves, you're also increasing the mycorrhizal activity as those leaves or that compost breaks down and, again, feeds the soil. We should also point out, too, that mycorrhizae aren't just waiters and waitresses feeding plants. They also help to offer them some protection from certain pests and diseases, like nematodes, for example.
Yes, actually, mycorrhizae will attack nematodes that are attacking for example, your tomato plants.
That's right. There are some circumstances, though, where you may need to add commercial mycorrhizae, and a lot of people don't think about this, but maybe right now you're building some new raised beds because you've heard about how great it is to have a raised bed in your garden. So you call up the sand and gravel place and order 5 yards of their gardener's blend, which in the case around here, it's usually some river bottom soil, a bit of compost, and probably some sort of fir bark or something like that. The problem is there's probably no mycorrhizae in there because mycorrhizae only survive where there is plant material. So if there are no plant roots in that mix, chances are there's no mycorrhizae. In that case, you may need to inoculate the soil with mycorrhizae. Now, the problem with going to the store and buying mycorrhizae is, how do you know that stuff in there is alive? And the fact of the matter is, you don't know if it's alive or not, and chances are it's dead. There have been studies done by scientists with their results published in peer-reviewed scientific journals, for instance, New Phytologist, which is a scientific journal, in volume 246. They talk about the viability of commercial mycorrhizae, and they say commercial product mycorrhizal colonization was less than 10% in both the old study of 2004 and the newest study in 2024, indicating that even for viable products, they have low symbiotic potential that is not improving over time. They're looking for regulatory enforcement along with the cost of independent product assessments in order so that people know that when they're buying something, they know that there really is mycorrhizal activity going on in that bag. But chances are, if that bag has been sitting out on a parking lot, it's probably gone through some rather severe temperature extremes, in which case that mycorrhizal may have gotten, shall we say, fairly cooked. And again, you're talking about mycorrhizal activity commercially purchased where you have a 10% chance of it being effective. Better idea. You have an area in your yard where you have plant activity, where you've got plants growing. if you don't have any soil problems, if you don't have any things like verticillium wilt or fusarium wilt, nematodes, things like that, take some of that soil and put it around your plants that you just planted in that new raised bed, because there's mycorrhizal activity in that soil you bring over. And you can't just put mycorrhizal activity fungi into a raised bed, a new raised bed, without plant material. Those critters need roots to feed on. So you plant the plants first, then you include the inoculant, the mycorrhizal laden soil, if you will, from other parts of your yard. And it'll live happily ever after and keep growing and thriving. And Pat, like you said, and all you got to do really is just keep some food there for the mycorrhizal activity. In this case, it would be the roots of the plant, and maybe add some compost and maybe add some mulch, but try to avoid rototilling as much as possible.
Yep. Another thing that we don't think of very often is an area where perhaps there was a shed and you removed the shed and it had a concrete foundation, and you remove that and you think, well, you're going to put a plant bed in there. There's not going to be any mycorrhizal activity. The soil has been too compacted. So that would be another instance where you would want to add some, as you said, inoculate from another part of your garden.
Right. When we usually talk about rototilling, we usually give you a pass as far as rototilling the first time, if you are dealing with a new situation like what you just described. So you can till in some compost, some worm castings into an existing piece of dead soil that didn't have plants growing in it to help give it a head start, and then put your plants in right away. This is why it takes years to really get raised beds to function effectively the way you want. It's a slow process, but it's worth it. It's worth the time. And by the way, a lot of people don't realize that mycorrhizal activity also can help those plants stave off drought.
I would like to add that some commercial potting soils will actually advertise that they contain mycorrhizae. And I would really question that if it's been sitting out on a pallet in the hot sun, like you said, or it's been driven across country in a 16-wheeler. You know, the heat is going to destroy that mycorrhizae.
Which goes back to what I always say, all gardening is local, and that includes buying soil products too. Try to buy your soil products from somebody local where that trip isn't so long. There are a lot of good soil manufacturers, if you will, potting soil companies within an easy 1 hour, 2 hour drive of probably wherever you live that can get it there quicker. And if you want to go one step further, go to your local nursery and say, hey, when are you going to get the next load of potting soil in that claims to have mycorrhizae in it? And if they say, yeah, it's coming in Friday, well, go there Friday and pick it up. Chances are you have a 10% chance of being successful.
Let me ask you a question. What do you think the mycorrhizae that come in the little foil packets?
There are a lot of just mycorrhizal products sitting on the shelf inside the nursery. And it's something like, what did I read? Like a $900 million industry now of mycorrhizal products that are out there. And you're taking a chance. That's all. You don't know. There is no, as this study pointed out, there is no way for the consumer to figure out if there are living mycorrhizal activity going on inside that bag you buy or that pouch you buy or whatever you buy.
So there's no way to test it, huh?
Well, there is, because they do it commercially. They do have tests, and that's one thing this study was arguing for, is get these home test kits out into the people's hands so that they can test the bag to see if there is mycorrhizal. And that's not a bad thing for a retailer to do. If they get products that claim to have living mycorrhizal activity going on in them, the retailer should be able to check to make sure that what they're buying is what they will be selling. And we should point out, too, that you only need, as Pat pointed out in her article, you only need to encourage the thriving of mycorrhizal activity through proper cultural practices. Pat, you talked about don't disturb the soil by digging or rototilling, and to create those pathways so you avoid compacting the soil. And also, I'm scared when I see these fertilizers that claim to have mycorrhizae in them, because Well, it's like
if they do, they're dead.
Well, if they do, they're or very small in number, and it really depends on the amount of phosphorus in that fertilizer.
Yep.
And you have to stop using herbicides and fungicides if you spray it on your soil, because a fungicide, I don't think, can discriminate between good guys and bad guys in the fungus world.
I think you could think of mycorrhizae as the beneficial insects of the plant world.
Yeah, there you go. and basically have something growing in your garden year-round to sustain the mycorrhizae during the off-season. Don't leave a bed bare in the wintertime. Like Pat said, have a cover crop in there. Have at least the old plant roots of whatever you cut out from there in there. Add mulch on top. That'll help feed the soil during the winter and keep encouraging the mycorrhizal activity. And again, you don't need to add as much phosphorus fertilizer, if any, if you're trying to encourage mycorrhizal activity. If you get a real good soil test done, especially in our area, you'll notice that there is a plethora of phosphorus in the soil. And you need to get that phosphorus level down to a point where mycorrhizal activity can really start thriving. So go easy on the addition of phosphorus, and that means looking at that middle number that you might see on a fertilizer bag. You'll see 3 numbers on the bag of any fertilizer. The first is nitrogen, the second is phosphorus, and the third is potassium. You want to make sure that second number, the phosphorus, is non-existent, a 0, or really low. Now, for instance, my go-to fertilizer, as you longtime listeners probably know, fish emulsion, because that has a phosphorus content of 1. It's a 5% nitrogen, 1% phosphorus, 1% potassium. My plants are doing okay.
I like to use fish meal. It's a little easier to work with than fish emulsion, but it's hard to find these days. I go to several different stores before I find it.
And describe fish meal for us.
Well, it's ground up fish product. I imagine it's the part that doesn't go into the fish market, and dehydrated and ground up. So it's got the bones and the guts and the head and everything. And it's got the nutrient mix that you pretty much described with your fish emulsion, but it's a powder, not a liquid. And so I can just sprinkle it on top of my bed before I plant. And fish emulsion it's smelly, and you have to mix it with water, and I just don't like it as much.
It attracts. When all I have to do is shake the bottle, and the cats come running.
I bet.
We'll have a lot of links in the newsletter about what we've been talking about today, the studies, the authorities who talk about how to increase the mycorrhizal activity in your soil.
Especially Jeff's book.
Jeff Lowenfels, we're going to have that chat on today's podcast that you can listen to, and you're going to learn a lot. And if you really want to delve into the subject of mycorrhizal activity, get his book, Teeming with Fungus, or is it Teeming with Fungi? I forget which.
I've got it right in front of me, Teeming with Fungi.
Fungi, plural version. Okay.
Yep.
So Teeming with Fungi, Jeff Lowenfels. It'll be a great interview. Pat Rosales knows a lot about a lot of things, including E minor and C sharp and other things in the French horn world. Pat, thank you so much, and thanks for the great article about mycorrhizal activity in the Sacramento County Master Gardener newsletter.
Okay.
There. Was that confusing enough for people? Let's move on to part 2 of our podcast today as we talk about mycorrhizae. Now, you may have gleaned from part 1 that if I told you the future of plant fertilizer was not fertilizer, you would probably have a hint as to what that might be. Yes, indeed. It's fungus and bacteria. Seconding that motion is Jeff Lowenfels. He's the author of several books about what's happening under your feet in the soil. Books like Teeming with Bacteria, Teeming with Fungi, Teeming with Nutrients, Teeming with Microbes. It's all about the magic that makes plants grow. So let's listen to our interview that we did back in November of 2022 with Jeff Lowenfels, author, happy guy, geek, and who better to help out to talk with Jeff is our own favorite happy science geek, everybody's favorite college horticultural professor, Debbie Flower. And she geeks out on the garden science with Jeff, who basically knows what he's talking about when it comes to soil mycorrhizae. As you might imagine, Debbie Flower had a wonderful time talking with Jeff. Well, I was busy thinking about buttered popcorn. Well, you'll have to listen to find out why. And by the way, if you listen to this entire episode, you get garden psychic bonus points, and it may just pop up on the final. You're probably familiar with Farmer Fred's 11 garden rules, and 2 of them are everything you know is wrong, and if it works for you, fine, but keep an open mind. And what you're going to hear in this interview is going to blow your mind. It's going to change the way you garden. For the good. You're going to save money. Debbie Flower is here as well. Debbie Flower, America's favorite retired college horticultural professor. And we are talking with author Jeff Lowenfels. Jeff has written many, many books. I remember interviewing him on the old radio show back in, I think it was 2006, about one of your first books called Teeming with Microbes. More have come since then. In Teeming with Microbes, you revealed the fascinating facts around the soil food web, all the tiny organisms that live in the soil and aid a plant's growth. Then there was Teeming with Nutrients, exploring how those organisms aid in the uptake of nutrients. Teeming with Fungi, where Jeff Lowenfels details the symbiotic relationship between plants and fungi, the most important organism living in the soil. And his latest book is Teeming with Bacteria. And Jeff lives in Alaska. And you're probably thinking, oh, so he doesn't garden. Oh, no. He even writes a garden column. He's had a garden column in the Anchorage newspaper for well over 40 years. Jeff Lowenfels, it's a pleasure talking to you again after a 15-year respite or so.
Yeah, it's a wonderful, wonderful introduction you did there. I'm wondering who this guy is.
Oh, but wait, there's more. I mean, you have a fabulous history, but one of my favorite parts about your life is the fact that you are a recovering lawyer.
Yes.
Yeah.
Yes. In fact, when I only had 2 books, now I have, I had a trilogy, so I changed the name into Lord of the Roots, which I kept. But when I only had 2 books, I used to bill myself as, because they were both on soil, America's dirtiest lawyer.
That's appropriate. Yeah. Okay.
Yeah, I thought that was, and so that was my moniker for a little while. But yeah, I'm a lawyer. When you can't do anything else, maybe that's what you end up becoming.
But the fact that you had a garden column for over 40 years.
Longest running garden column in the United States, correct?
Actually, it's 47 years now. I've been told it's the longest in the world.
Wow.
From a gardening column perspective, and maybe in terms of consecutive weeks, from any kind of column. But anyway, it's a long time. And the reason why I do it is because when you're not there, my particular newspaper puts your picture in the paper, and it says, XYZ columnist is on vacation and will return in 2 weeks. And of course, if you don't write the column, you think that's interesting. If you write the column and you're thinking about it, and you're a lawyer, you begin to think, that just sort of advertises he's not home.
Good point.
Yeah, so I always have a column, and it's become a religion. It's like Ty Cobb, the baseball player. I don't want to miss a week, and I don't want anybody robbing my house. So I always have a column. Of course, the goal is not to repeat yourself, which I don't.
That would be tough over 47 years every week.
There are only so many ways you can tell people to grow tomatoes.
A lot of people think that, well, it's Alaska. How can you garden in Alaska? But it's probably not very different than living in a city in the mountains, like maybe Colorado Springs, or here in California in the Sierra, Truckee, California at altitude, right. And you have a growing season of a couple of months. You can grow anything that the people in the flatland can grow. It's just got to be a little quicker. That's all.
Well, yeah, and actually it's not as quick as you think because of our daylight situation. But yeah, one of our favorite phrases as gardeners in Alaska is how can you stand the weather out there? Outside. That's what we call, where you live, we call outside. Outside of Alaska is outside with a capital O. And so how can you stand the weather outside? Because we really have a season that starts, definitely in the ground by Memorial Day weekend. And then, of course, we can continue sometimes right on through October 15. That's a long season.
Yeah, when I look at this gardening calendar, when to plant vegetables in Anchorage, Alaska, at garden.org, the dates I see on this gardening calendar look very much like the ones I adhered to when I lived in New York and New Jersey. Right. Typically, nothing before Memorial Day. Yeah, Mother's Day, right? And then through the summer, and then frost comes and it's over. I'm amazed.
That's right. I mean, but I have to say that this is a big change from when Fred and I first talked, and certainly an even bigger change from when I got to Anchorage in 1975, 73, 75. We have added probably 20, maybe even 30 days onto our growing season. So those who are listening and don't think that global warming, of course, I don't have to convince anybody in the Sacramento area that global warming doesn't exist. You're crazy. It does exist. And I'll give a statistic that people always go nuts about. They used to keep records in Talkeetna, which is a little further north than Anchorage. What a wonderful name, Talkeetna. It's the town that has a cat as an honorary mayor and has for 20 years. But in any case, they kept records there, and they kept those records. I think they started sometime around 1875 or thereabouts. And lo and behold, we've added well over 100 days to the growing season.
That's amazing.
100 days.
Wow.
So, it just smacks you in the face. And, of course, we have another saying that gardeners in Alaska like to use that you might not appreciate, and that's global warming. It's our turn now.
Yeah.
Oh, okay. Yeah.
Yeah. So one of my friends grew a couple of years ago, maybe 2 years ago, an okra.
That's
the first okra I know of grown in Anchorage, and probably all of Alaska. It's very hard to grow okra unless you have a nice warm season, et cetera, et cetera. And sure enough, grew okra. I couldn't believe it. It was just a stunner. It's always an interesting experience watching our climate change, and it's amazing, just completely different than it was when I first got there. But yes, we garden, and we all garden. And the reason why we garden is because you go nuts during 9 months of winter. And it's not so much the cold as it is you can't garden. It's dark. It's at least the ground's frozen. So it's just, and I can't convince my readers. I try. Anybody who gardens and has a long season like we do in winter should have lights, period. I mean, it's just, you spend all that time for 2.5 months in the vegetable garden, you can be growing vegetables all winter long. Goodness gracious. So,
yeah, I would think stores would have plenty of grow light fixtures and just like little greenhouses.
Absolutely. And, of course, cannabis has been legal in Alaska since 1975.
Wow.
In the privacy of your home. And so the grow light business is it's well developed in Alaska. And grow tents, there's 2 or 3 good grow stores. And it's something everybody needs to do everywhere. But in a place like Alaska or Fairbanks, it just makes tremendous amounts of sense because it is such a long season. Nonetheless, the plants grow exactly the same way, so it's the same kind of excitement, the same kind of satisfaction as you normally get when you go out and plant out in the garden. And I would say there's one other difference between the Alaskan gardener and maybe the gardeners where you are, and that's that many people in Alaska have plants that they brought up from the lower 48 states that are their family. This is my grandmother's Christmas cactus, or this is my I took this clipping from my grandfather's blah, blah, and they come up the highway with it in the back of the Volkswagen bus. And you don't want that to die,
right.
And so that gets people going in the wintertime. You got to keep those special heirloom plants alive.
Yes, I have several of those in my house that I take from place to place. And around here, the local utility was, at least when I was teaching was wanting us to teach how to grow in basically a metal box, a truck body or something like that, and have the lights on at night so that they could balance out power usage. Everybody's using the power during the day, then everybody goes to bed, the power need goes down, and the utility wanted us to teach how to grow at night inside these enclosed environments so that they could even out their power needs.
Well, that's wacky.
Isn't it?
Yes. Wow. But are greenhouses, outdoor greenhouses, cost prohibitive in Alaska?
No. I mean, if you're a serious gardener, everybody has an outdoor greenhouse. Whether it's a little plastic hoop situation or whether it's a permanent deal that's, we don't necessarily use glass. There are a couple of those, but we've got the outdoor greenhouse for the tomatoes because if the temperature drops below 55 degrees at night, you don't get tomatoes.
Right. And
tomatoes are they were the holy grail of gardening in Alaska. Mm-hmm. And so, everybody seems to have a little outdoor greenhouse, some bigger than others. And we grow cucumbers and tomatoes and, peppers.
So you have a lot of whitefly control information then.
We have a lot of whitefly controlled information. We try not to get whiteflies.
Uh-huh.
And from my perspective, when you have an outdoor greenhouse, the whiteflies come from the nursery where you buy your greenhouse seedlings, so grow them yourself.
Okay.
That's it. Nothing worse.
You're right. It's a difficult one to...
And particularly now, since I think we have fewer insects that might take them out. This year I noticed we don't have any mosquitoes in Anchorage anymore.
Seriously?
It's just dumbfounding to me. We have far fewer birds,
wow.
But we don't have any mosquitoes.
Are you drier than you've been?
We had the driest spring, half of summer, and then we had literally the wettest other half of the summer.
Oh.
So we've had both extreme. It's very interesting. We are, again, I think, the bellwether, so you should be keeping an eye on all this stuff. We know we're losing insect populations. Mm-hmm. To me, it's just dumbfounding, the bird population differences.
Mm-hmm.
So we all ought to be worried about it. And today I hear that the United Nations indicates that, we got to have a 47% reduction in some incredible number of emissions, and we're at 2%.
Oh, boy, yeah.
So would any of this have a bearing on your congressional run that you attempted earlier this year for that open congressional seat?
Well, I really left myself open for that one. And I have to say, it was one of these crazy experiences. For those who don't know, we had a beloved, long-time congressional delegate. We only have one, and he died. And so there was a special election. And many of us, probably because of our stupor from COVID isolation, decide, okay, I could do this job and I could do a good job at this. I'm going to put my name in there and run for this office. And then we discovered that there were 50 other people
wow.
who got the same idea, including Sarah Palin, a guy who had been running against our representative for 6 months prior to that, who had a massive fortune, and a guy who had run for senator a couple of years ago, had about, $18 million left over from that. Anyway, it was one of these situations where, because of the press rules, it's not like gardening. If a carrot doesn't come up, you go look at another carrot. You've got to be fair. And so there were no debates. How do you debate 51 people? There really weren't any one-to-one interviews, because how do you do that unless it was public radio and they had to do all 51 people?
Wowee.
Jeff, you work for a newspaper.
I work for a newspaper, and thank God the newspaper was gracious enough, I think, to sit back and say, he's going to lose. Let's not get rid of his streak. Frankly, I was the garden party candidate.
Okay. All right. Good.
Not so much that. I mean, to be honest, I've got some name recognition as a result of the column up in Alaska. And it's one of those situations where I was an attorney. I represented native corporations. I did mining law, environmental law, pipeline law, public utility. I did all the things, and more important, I represented clients, which is what a congressional person does, and I dealt with the acts that ended up resulting in the formation of the legal system that Alaska reacts to the federal government from, called the Alaska Native Claims Settlement Act, which was passed in the 70s and 80s when I was there and integral. And in any case, I had the qualifications, so it was going to be fun, and then it turned out not to be so fun. I have to say that I had one gardening moment. There was only one event where they allowed 14 of us to appear in front of a group at breakfast. And we each got a minute to say our piece.
A minute.
And then they asked us 5 or 6 questions. We each got a minute to answer a couple, 3 or 4 questions, and then they had the paddle thing. We hold the paddle up, and you want to club a couple of the people there. In any case, I'm sitting next to Sarah Palin, who's a friend of mine. I don't agree with her politics at all, but I know Sarah well. I had just written my column, and in my column, I always have been pointing out, don't rake your leaves. It's a waste of time. It's bad for your yard. It's a terrible thing to do. Those leaves will decay. They disappear. They don't smother once, blah, blah, all the whole bit.
Good stuff.
Then they ask, and we should talk about that a little bit because I think it's an interesting topic of a conversation these days that has to do with the soil food web. But in any case, Sarah is sitting next to me, and she begins by, and I'm going to go out to my dad's house in Wasilla, and I'm going to help him rake leaves. And I just couldn't help it because of the wise ass that I am, or wise guy that I am. Sorry, I just blurted out, "You're not supposed to rake your leaves," And of course, everybody knows who I am. I mean, I'm the gardening. I'm Jeff the gardener. I'm not Mr. Lowenfels, the congressional delegate. And of course, I got a gigantic laugh, embarrassed the hell out of poor Sarah. Then it was the only little funny thing that happened the entire campaign for any of that. So that was it. That was the
but don't sell yourself short. There were like 48, 50 candidates, and you finished 8th.
No, I think I was 7th, actually. But
one guy dropped out.
Yeah, one guy dropped out, but it's still, with 5,900, more than 5,900, almost 6,000 votes, you made a good representation for yourself, even though Santa Claus did beat you.
Yes, he did, and I like to moan and groan about that son of a gun. What a he was running off his name, and people thought it was funny, And then I got to sit back and say, wait a minute, you were running because you were a gardener. You're the gardener, So you were doing the same thing he was doing. But I have to say that the woman who won. And she called after that vote came out. She called because it's a ranked choice and blah blah blah. And she called me, and the first thing out of her mouth was a really clever, cute gardening quip question. It was just a terrific. This woman, you watch her. Her name is Mary Peltola, and she walks on water. I have never met a politician, and I dare say a person, who's more charismatic than this woman and more sensible. It's unbelievable. And better yet, for a state like Alaska, to have a native who becomes the leader, not a leader, is really important. So anyway, it was a terrific experience. I'll never do it again. I thought writing a garden column was hard. I thought writing books about gardening was hard. No. Sitting around wondering what you're supposed to do when half the people have COVID, nobody's answering doors, and there are no debates or public forums, and you're running for Congress. Okay, I'm done.
All right, let's move on to let's sell some books here. Teeming with Bacteria is your new book, the follow-up to Teeming with Microbes, Teeming with Fungi, Teeming with Nutrients, Bacteria, the missing link in all of this. And according to your book, this is going to be the next hot thing. Are we going to be inoculating every seed we plant from now on?
Not right away, but at some point in time, we're going to certainly be thinking about it. Let me put this in the whole thing in context so that people know why I wrote this particular book. When we talked about Teeming with Microbes in 2006, it was an eye-opener. It was really...
It was.
And it was Dr. Elaine's science and ability to be able to go out, Dr. Elaine and go out and talk about this stuff and deal with the ridicule that people threw at her when she said, here's how the system operates. There is photosynthetic energy. This is a gross summary. The photosynthetic energy, part of it, maybe 30-40% of it's used to produce exudates. They drip out of the root system. She called them cookies and cakes. They're carbon-filled molecules. They attract bacteria and fungi that are in the soil to the rhizosphere, that little area right around the root system. And they're happy. They need that carbon because they don't photosynthesize.
Right.
Along come nematodes and protozoa, and they go, geez, we're hungry too. And so they eat the bacteria and the fungi. And they do so because they also need carbon. They're not able to photosynthesize. You and I eat toast because we need carbon. They don't need it all, and so they poop out the excess. And the excess that gets pooped out basically is in plant-usable form. It's got the right, we learn from Teeming with Nutrients, the second book, the microbes, bacteria, and fungi put the charge onto the nutrients so that they can get into the plant. That's basically. And so you have this production in the soil that then migrates to the plant, and then Teeming with Nutrients talks about how they get absorbed and then what happens to them once they're in there. Now, along come a lot of studies on mycorrhizal fungi, which was a paragraph in Teeming with Microbes. It was revised. I put a whole chapter in, and finally, it came to be that there was enough for an entire book on fungi, and so Teeming with Fungi added to the way plants get their nutrients, and these mycorrhizal fungi that are in that area are attracted by the plant. It's not the fungi going into and they go in between plant cells, and they trade water, nutrients, particularly the metals, and they get the exudates. They have a nice symbiotic relationship. They never invade the cell, but they're there. So everything is happy and copacetic. And then a friend of mine in about 2010 sends me a one-word text, rhizophagy. I had no idea what he was talking about. I looked it up. There was real, I know rhizo, root, phagy, eat. Okay, what the hell was he talking about? I could not. It didn't make any sense. And he wasn't the kind of guy that I call up on the telephones, and we have long conversations about these kinds of things. They just send it out of the blue. Okay, lo and behold, there was a discovery in 2010 by an Australian team led by a woman with a hyphenated name that I always butcher.
Dr. Chanyarat Phuongphuonhain.
God, I wish I could just record that and push a button anytime. Anyway, there was also another woman who I don't think I gave enough credit to. I think her name was Miller. But in any case, this team was funded, and the funding ran out. But what they discovered using a conical microscopy, a special kind of microscopy, they discovered that bacteria were all inside meristem root cells. And they theorized that what was happening was that you were getting the meristem, very thin-walled cells, very young. That's where they start as meristem, that opened up and let these bacteria in, sort of ate them. And then close up around them again. That was sort of what they came up with. They really weren't sure exactly what was going on. That was their theory. The funding must have run out. And then it was picked up by a guy in Rutgers University in New Jersey named Dr. James White. And Dr. James White has done some unbelievable work. And so now we have those bacteria that Dr. Elaine taught us were attracted to the rhizosphere. Some of them are not eaten. And that's when the rhizophagy story begins.
You know what? I read the book. I read the entire book. I loved it. I learned things.
Thank you.
Opened new worlds to me. And one of the things I really, really loved was pretend you're a bacterium. On page 109, it starts.
Yeah.
And it's like the Disney ride of the bacterium from the soil into the plant. What it does in the plant, and then it gets spit right back out. That was a hoot.
Well, that's funny that, Dr. White, who I wrote Teaming with Microbes basically for Dr. Elaine Ingham. She's the guru of the soil food web, and this book doesn't take anything away from her by any means. Like, goodness gracious. But I was talking with Dr. White, and he loves that particular passage, by the way. Oh. But I said, how come everybody doesn't know about this? And he went, I can't get traction. I can't get nobody. And so I said, I'll write a book. And that's where the book came from.
Wow. Rutgers, by the way, is my I'm a Rutgers alumni, yeah.
If I could go back to school.
Yeah, right. I'd do it too. So much new stuff.
I'm thinking maybe they would take a 73-year-old who would pay them. But in any case, let's talk about this rhizophagy. First of all, the word itself.
Please.
I'm an ex-New Yorker. I may live in Anchorage, Alaska, but I pronounce it rhizophagy. I'm blunt.
Google likes to say, I can't even say how Google says
rhizophagy or something.
Rhizophagy.
They emphasize the O.
I figured out why the other day, and you can relax and go to rhizophagy like I say it.
Okay.
She was Australian, for God's sake.
Oh, yes.
The Australian pronunciation.
Okay, I'll go with that.
Doesn't that make sense?
All this stuff in plant biology and plant names, when I would teach plant ID, and students would stress over saying that the names of the plants, the Latin names, I'd say just say it with confidence and a smile and look the other person directly in the eye.
Yeah, and then just say that's the way they say it in the Christian Science Monitor.
Or now, what is your consumer definition for rhizophagy?
Okay, yeah, okay. So here's what happens. So let's pretend you're a bacteria. What happens is the bacteria form a slime. Everybody knows about bacterial slime. The example, of course, is that's what's on your teeth every morning, and everybody is licking their teeth right now. But that bacterial slime contains lots of different kinds of bacteria in the soil, and it forms right up there on the meristem area. The very tip, right after those slough off cells, etc., they begin to smell popcorn, buttered popcorn. And like anybody else in the world, they go, I wonder if it's free. In fact, it smells like there's a whole popcorn factory in there looking for bacteria. And so they move through that's butyric acid, which is released by the plant, and they move through the cell wall into what's known as the periplasmic space. And they go, what the hell happened there? Where's the popcorn? Well, there is no popcorn, but when they move through there is a spray of superoxide, which is designed by the plant to strip off the cell wall of the bacteria, or bacterium, let's put it that way. The cell wall gets stripped off. The bacteria goes, whoa, wait a minute, I don't like that at all. And 2 or 3 things happen. The first is the bacteria says, geez, I got to weaken this stuff or I'm dead. And so they produce nitrite. The nitrite is converted to nitrate, and both the cell wall and the nitrate are then continue through the membrane into the cytoplasm, where they're nutrients. Up to 30% of the nutrients come from this nitrogen fixation inside the root. Now, okay, you could stop right there and it would be, eyeball dropping, but it continues. Now you've got a bacteria in there that doesn't have a cell wall. But it's still alive. I think they call them, I'm trying to remember, L-plasts. It doesn't have a cell wall, and they divide every 20 minutes. It divides. And lo and behold, it divides probably even quicker than 20 minutes, because you don't have a cell wall in the way anymore. And at the same time, it's producing this nitrate to be an antioxidant to the superoxide, which incidentally, the superoxide production, the plant goes, oh, Jesus, I got to make sure it's not killing me. It's going to destroy my cell wall. So it causes the plant itself to strengthen its own cell wall. Whoa, heady stuff. And it continues on through the life of the plant, incidentally. Then the circulation takes over, and these little L-plasts, they circulate around the inside of the meristem cell. Now, you're probably saying, what does this look like? Picture a tofu container. You know, that common white plastic tofu container with the water, and then it's got the tofu in the inside. So the outside, that white container, that's the cell wall. They then move into that watery area. That's the periplasmic space. And lo and behold, it cycles and it goes around. Now, another thing is happening. The bacteria are producing one of their phytohormones, because a lot of bacteria make phytohormones. This one, ethylene. Ethylene causes the meristem cell to grow, to stretch. So you've got the nitrite, you've got the ethylene, you've got the cell wall, this L form circulating, multiplying, and they end up forming quads. They form these quads, sometimes sixplex, but mostly quads, and they circulate around, producing this ethylene, taking a little bit of carbon from the cell wall. And everything's happy until they get too many. And they begin to back up against the cell wall. And when they back up against the cell wall, the ethylene stops circulating and instead causes a tube to grow in the meristem cell wall. And bingo, the tube is known to me and you as a root hair.
Ta-da!
It's that meristem cell. It's part of that cell. You know, it's not a separate cell, and it's very thin walled, which is probably why it allows nutrients in there. But the real reason why it forms is because of this ethylene bacterial backup. And in go the bacteria, a little tidal wave creates a pressure, and boom, they pop out of the tip of the growing hair. And boom, it closes up. And more of them come in, and it grows, and boom, they grow out. We can go 4 or 5 times. They can open up and drop out or throw out or eject the wall-less quads of bacteria, and they, in the soil, use the nutrients there to regrow the cell walls, and lo and behold, they multiply, and
they say, that was fun, I'll do it again.
Right. And they go back in and they do the same thing again. Unbelievable. So when you don't have the bacteria, you don't have the root hairs. Who knew? Not me.
And there was but you cited, I don't know if there were experiments or cases where people did grow plants without the bacteria, and the plants, lo and behold, had no root hairs.
Right. They had no root hairs, and their roots themselves were all deformed and grew in the wrong way.
Yeah, that was pretty amazing. Grew in the wrong way.
And then, what even more amazing, when you put the bacteria in, they grew back the right way.
Correct me if I'm wrong, but my understanding from the book was that directional growth had to do with metals that were brought into the root by the bacteria that helped the plant orient to gravity. And without the bacteria bringing those metals in, there wasn't that ability.
I don't know if I put that in the book, but it makes sense to me.
Okay.
It makes a lot of sense. It might be, I wrote the
There's
book.
a lot of information in that book, yes.
I know, and I just read it, it came out October 27th, I guess. September 27th.
A month ago, yes.
And I had to pick it up and read it. I mean, and if we can interrupt just for a second, we're talking bacteria, and people really need to understand bacteria. So let me do this. Google bacteria, a head of needle, a head of pin, and you'll see pictures in the images of they were too expensive for me to buy and put them in the book, but there they are. And so we're don't think of one car in a driveway. Don't think of that as a bacterium. Think of the Hartsfield or the airport in Atlanta. That's bacteria. They're everywhere. The 5-second rule. Last week, and if you can find this on Google, it's well worth getting. Googled bacteria tongue cell.
Oh boy, do I want to?
a single tongue cells from someone's mouth.
The pictures I'm looking at look like Hostess Twinkies.
Rod-shaped bacteria.
Gazillion bacteria on this one cell thing. I mean, and of course in America and every place else in the world, we study dinosaurs.
Yeah.
Because they're useless. Well, instead of studying bacteria and microbes, which are so important. So one of the problems in the book was you got to list them. Which ones do what? They're not language that we're familiar with. It's just like plant names, and people are not really familiar with them. They're much more familiar with plant names, and we need to change that system. Stop studying dinosaurs. They're useless. The oil and gas they produce is useless. We need to study bacteria, fungi, nematodes, protozoa, all that stuff. And we're at the point now where the databases exist. Our phones will have applications where we can learn a lot of this stuff. But I digress. Look up bacteria. Think about the numbers, the sizes. They're so incredibly small. They have flagellum because they're so small that if they tried to row in water, they couldn't get anywhere. The shapes that they create are because of the water. I mean, the movement situation. They are absolutely spectacularly fascinating organisms. But the fact that they enter a plant and create root hairs and repeat doing it changes the soil food web in a serious way. So, the 2006 version, plants were farmers. They threw out the nutrients and the exudates, and they ended up farming what they got, and then they brought that stuff inside. Now we know that they are also ranchers. They're taking in the sheep, shearing off the wool, eating the occasional pork chop, and then putting the rest out into pasture again, so they can regrow the wool and come back in and have the process repeated. So they're farmers and they're ranchers. It's really a very big change. Again, not to take away in any way whatsoever from Dr. Elaine Ingham, but Dr. James White really and his students really have come up with a unbelievable, fascinating situation. I mean, it's just who would have thought? And it's only because the new kinds of microscopes and the ability to be able to dye test what kind of bacteria you have.
Yeah, technology advances. Your books, we've said the title, Teaming, but talk about how you spelled that word.
Right. So I spell the word T-E-A-M. You want to team with microbes. And the reason why you want to do that is because you want them to do the work instead of you. Gardeners like to think that we're in control. We are the boss, and we do this and do that, and we only mess things up, basically. So if you team up with the microbes and listen to them, you will end up with a wonderful yard, not just your garden. And indoor plants too, for that matter. The system that works outdoors also works indoors.
Debbie Flower is here. Jeff Lowenfels, the author of Teaming with Bacteria, is here. The Organic Gardener's Guide to Endophytic Bacteria and the Rhizophagy Cycle, or something like that. Explain, Jeff, what endophytic bacteria means.
Right. Actually, I say endophytic.
Okay.
Sorry, Fred. You were right. I'm, just little different. That's all. Right. Endophytic bacteria are bacteria that live and there are incidentally endophytic fungi that live at least part of their life inside a plant, and they don't do harm to the plant. So we've just described one kind, the rhizophagy bacteria. Those are endophytic bacteria. They spend part of their life inside, and then they get the rest of their life in the soil. There are other bacteria that get into the plant in a different way. They sneak in through cracks as roots begin to branch. They come in through stomata. They come in through injury, although not quite as often, because who wants injured plants? And they get into the plant and they live inside the plant. First of all, why would a bacteria want to live inside a plant? And the answer to that basically is less competition in there.
Mm-hmm.
Well, there's buttered popcorn in there, too.
Well, there certainly is down in the root system. I'm not quite sure there is up into in the upper halves of the plant. Incidentally, if you have too much of that butyric acid, it begins to smell like your stomach, vomit.
Ah.
I know this because when I was in 10th grade, we had a biology teacher who decided he was going to show us osmosis. It was an osmosis, which is the one that's in the... Anyway, he went over and by the window and he poured a tablespoon of butyric acid, but he slipped. And it went into the vent system, and they had to close down the entire school for 2 days. Anyway, it's very strong smelling stuff. A plant only needs to produce a teeny little bit of it. So they have food sources inside. You know, there's sugar inside plants, and some pretty good stuff in there. And basically, there's no competition, and it's just a nice situation for them. Why would the plant let them in there? That's more important question. Plants understand that bacteria are usually bad, but there seems to be this dance where they get sprayed, and ROS, et cetera, et cetera. They create a situation inside the plant that strengthens the plant. So plants are able to take abiotic stress like heat, cold, wind, and biotic stress, like a pathogen coming in and trying to do the other bacteria say, no, get out of here. This is our area. And they take out the pathogen. The plant gets helped by it and must recognize this.
It's almost like an exercise.
Yeah, and it becomes important in many different ways in addition to just to the plant itself. So, for example, with regard to tomatoes and cannabis, which have hairs, any plant that has hairs. This was something that in the book was speculated on because the research hadn't been done yet. Root hairs look an awful lot like the trichomes on cannabis. Is there a connection there? And there were certainly bacteria inside there, but now it's pretty well understood that there are bacteria inside the trichomes, both on tomatoes and in any trichome. These bacteria get sprayed with superoxide and other things by cells in the plant cells, and in the case of cannabis, they get sprayed by cannabinoids, and so they help production of cannabinoids. Whoa.
So potentially we could influence what, in the case of marijuana, what cannabinoids are in the crop by selecting the bacteria that are in the plant?
Exactly. And in fact, that's already happening. Incidentally, I try not to use the word marijuana because it's the word that was used by the DEA guy, Harry Anslinger, who was trying to make it like it was a bad thing and the Mexicans did it. Yeah, so I use cannabis wherever I possibly can.
You could say hemp if you wanted to.
Well, not really. It's THC hemp. Yeah, it's hemp. Yeah, it is hemp.
But we could do that with tea, or camellia tends not to have trichomes, however.
But it definitely has bacteria. I can guarantee you that.
We could influence the flavor of tea by choosing the bacteria that are in the plant. Pretty fascinating stuff.
Yeah, well, again, I mean, it's so fascinating that in fact, if you went back and took a landrace, well, they did it with corn. If you have 400-year-old corn and kept not breeding it, and there are strains we can go back, it has the same bacteria 400 years later that it did 400 years ago.
So if we were to change the bacteria that we allow these plants to have or not have, we could end up killing the plant.
Precisely. And we can end up feeding the plant at the same time because you get nitrogen fixation. And so when you buy a landrace strain of cannabis, it's because of the bacteria in that cannabis seed. What happens is the end result of all of the endophytic activity is that these endophytes end up in the seed. They get into the flower zone. Again, hark back on the pictures, thousands, a gazillion of bacteria. They end up inside that seed. They get inside that seed coat and just inside, and bingo, they're carried on to the next generation. So if you're a gardener or a farmer and you're using coated seeds, you may be killing those guys. You may be replacing them with a fertilizer instead of letting them get into the soil where they're needed to do the rhizophagy cycle. Or if you sterilize, that's a bad thing. And a lot of cannabis growers do that. A lot of tomato growers like to sterilize their soil and sterilize their seed. Craziness. We've got to let nature do its thing. And now that we know about what these bacteria do, bacterium is single, it's just all the more reason to be organic.
You point out in your book the fact that in the 1800s there were farmers who were moving soil that they had grown legumes into new patches of soil and found that the legumes they grew even better.
Right. And so a lot of people discovered a long time ago, and it's sort of Dr. Elaine's thing. If you find a plant that's doing incredibly well, you find that orange grove where all the plants are ganga, you get some of that soil up near the rhizosphere and use it on your plants. Mm-hmm. That's the way you do it. And if someday we'll have a gigantic database, and is it the fungal bacteria ratio, et cetera, but it's certainly, it has something to do with the rhizosphere.
So does that throw the crop rotation idea out the window, that we should rotate our crops to prevent buildup of disease?
Yeah, again, I think there is this intersection between disease and practice. And if you're a farmer, the only thing you're thinking about is your end result is the money you're going to make. If you're fully organic, you generally don't get these diseases.
Right.
But how do you get to be fully organic without getting them? And that's the big things. I certainly advise people who grow tomatoes, people who grow cannabis, people who do container gardening unless they know they have a root problem, to use the same soil and not to rototill it. Mm-hmm. Just put the seed in and let the seed grow. It'll use a lot of the exudates that are still in the soil. It'll grow down through the areas and the hairs and not hairs, because now we know what hairs are from, but it'll go through the roots themselves and use a lot of that organic matter, et cetera. All the right bacteria are in there, all the right fungi are in there. It's just a beautiful system. Mm-hmm. And it's not just the bacteria. I don't want to give people the wrong idea. There are some endophytic fungi as well that go through the rhizophagy cycle. They're I understand, yeast. It's not the same thing as with all these bacteria. It's really an unbelievable discovery.
It is.
30% of the nitrogen. And it's just one that needs to be told. I remember going to a garden writers conference in 1998 or 99. It was in Seattle area, and I was with Dr. Elaine Ingham, and I introduced her. And of course, we had fights at the garden writers over the years between organic and chemical, to the point where literally there was one meeting in New York where I thought that's the end of this organization. We had such an incredible fight between organic and she got up. And I asked the crowd before she got up, I said, how many people here know what a mycorrhizal fungi is? And we were talking 750 people there, New York Times on down. Not one person raised their hand. Nobody. You ask today a garden writer what a mycorrhizal fungi, they know what a mycorrhizal fungi is. Mm-hmm. And they know what the soil wood web is, and they don't write about using chemicals unless they've been paid, it seems to me, by somebody to do it.
Mm-hmm. You point out, too, in your book, going back to seeds, the fact that people tend to store their seeds a little too dry, that there should be some moisture associated with that. Right.
Well, a lot of people take all the oxygen out of the container and keep it quite dry. It's really the oxygen you got to make sure it has, because there's living bacteria in there, and those seeds actually breathe. Mm-hmm. It's kind of standard practice, to put them in a little film canister and freeze them up and get rid of all the air and all that kind of stuff. It's crazy.
I like your recommendation about spraying your lawn with compost tea made from compost that was heavy on grasses taken from the lawn when you want to garden with endophytes.
Well, yeah, it's just not just the compost tea, because a lot of people will point out that there is a dearth of studies that compost tea is really great. But if you use compost itself, it's just made from the same material. It just makes sense.
Which is better, compost or worm castings?
There again is a very interesting situation, because on some plants, worm castings are better, And for some plants, thermal compost is better. They have a different bacterial base. Each one is different. And I didn't know that. I mean, I sort of intuitively one's thermal and one goes through the body of the worm. But it's very interesting that there's research and if you're growing strawberries, it may be that one's better than the other. And it's worth doing the experimentation to find out. Particularly if you're a commercial grower, but if you're trying to grow that pumpkin for the fair, my God, it makes sense to discover which is which, what's best, and we're getting to the point where there'll be published, not databases, but published lists. And I've got a couple, and I've got several listed in the book. There've been a lot of research done. Again, because of the use of the words, the two bacterial nomers, or whatever the hell they are, it's hard to get the general public's attention about this stuff. If we could say, the rosy bacteria or the pink bacteria, then people remember, but it doesn't work that way.
Right. With the names they have. There's a bunch of books designated as the Science for Gardeners series, and you're involved in that, yes?
I don't know. Am I?
Oh, well, where did I read about it? I read that it was 6 books, 3 of yours, teeming with nutrients, teeming with fungi, teeming with microbes. How plants
soon to be teeming with bacteria, I would hope.
Well, I wrote bacteria ? In my notes because I didn't see that was included.
It just came out 2 weeks ago.
Oh yeah, so it needs some time to to step up.
So are you saying he should get a lawyer?
No.
He might know one.
But I need shows like this to spread the word, and not because of me or my writing, but because of Dr. White and his students. I didn't invent any of this stuff, just as I didn't invent, teaming with microbes either. I mean, these scientists deserve Nobel Prizes. This is key stuff, and the reason is because we're going to see a day. We already see it with certain products, and we should talk about them. But we're going to see a day when you're going to be able to go to your nursery or go to your farm supply store. You already can at farm supply stores, and buy specific bacteria that work and feed your plants. This is where nitrogen is going to be coming from, not from urea and things that are causing climate problems. They're going to be coming from bacteria that go into the plant and feed the plant and give the plant what it wants.
We hear a lot about mycorrhizal critters living in bags and boxes that you can buy at the nursery. Can those survive standing or sitting in a parking lot on hot asphalt?
Yeah, I think mycorrhizal fungi can. Obviously, they exist in Sacramento in the middle of the summer where it's 108 degrees, and so I don't think you got a problem there. But they have a shelf life. It's certainly no longer than 2 years, that's for sure. They tend to be ubiquitous after a while. I mean, in other words, if you're using them year in and year out, they're there in your soil. So you would use them like we do in Anchorage. We do a lot of transplant stuff. So we want to set up a mycorrhizal situation as early as we can. We roll our seeds in it. But yeah, you got to make sure you're getting a good product and not one that's 4 years old, et cetera, et cetera.
Do you think they're able to go into their resting stage, spore stage for fungus?
Yeah. Oh yeah. For fungi, yeah. Yeah, my conversations with Dr. Mike Amaranthus indicate that they're there. It's fascinating stuff too. But the bacteria are different because not every bacteria turns into an endospore, which is basically the form you want to have to be able to have a good shelf life.
So they're not. They're a little more fragile.
Well, there's one that you have to. It's got to be freeze dry, and you've got to get facilities that are able to handle that. But there's some bacillus that work very well, and you can get, and cannabis growers are beginning to use it. Aspergillus is another one. There are a few that are readily available and you can use and need to experiment with depending on what your crop is. It's the future that people are looking at, and if you follow what we would, excuse me for being this way, but what I would consider to be, some of the evil companies, they're beginning to merge, to my thoughts. They're producing and studying and researching bacteria to replace, I think, a lot of the chemicals that they currently sell. And the future definitely is going to be a situation where your wheat field is going to be fed by bacteria mostly and not by urea. It's coming.
That's wonderful. Right? That's what we need.
And
yeah, we have to have it. I mean, we've only got 60 some odd years left of soil. Seasons left of soil. It's blowing away. All of these agro practices destroy soil structure. And by the way, soil structure starts with bacteria. Mm-hmm. Bacteria produce that slime. That slime sticks together particles of soil. Those particles of soil become bigger aggregates as they stick to each other, and you get the fungi that weave them all even into bigger aggregates. And once you destroy that, either by rototilling or using a chemical, we end up with bad problems. And it's not fair for big agro to ruin our world, because that's what's happening.
I love your definition of heirloom tomatoes. You call it a strain of plant adapted to its locale. That's perfect.
Yeah. Yeah, and that strain is probably because of the bacteria that you've added to the system.
Yeah, and so people trying to grow brandy wine heirloom tomatoes in California, you don't have Pennsylvania soil. It's not going to work.
Right.
Well, it'll be all right.
It's not all right.
It isn't brandy.
You got a tomato.
Like brandy. Well, when you're in Alaska, any tomato
you get is a prize.
Yeah, actually, you're right though. Brandy wine is one of those ones we always, when you start growing tomatoes, you try it. The first couple of years, you may get one good one, but they're not like your heirlooms. There's a reason heirlooms were developed.
Mm-hmm. All gardening is local, and we've found out that all bacteria is local too. Not all of it, because you're transporting it around in those seeds. So when I buy territorial seeds and they ship them up to Alaska, I'm getting the bacteria that's on that cosmos. It's going to make that cosmos grow well. So that's the beauty of being an organic grower or gardener. Your bacteria are being shipped right along with those seeds. You don't have to roll anything in anything.
It doesn't frighten you that we're moving bacteria cross country into foreign countries? That has me a little agitated.
Yeah, I think it's happening anyway. If not by traveler, it's happening by wind. I mean, these guys are ubiquitous. They're unbelievable.
By the way, kudos to your editors at the book, because they do a fabulous job of making it very accessible to the common gardener.
It's a great book. I really enjoyed it.
Well, I tell you what, there's one particular editor at Timber she's a great editor, and she's really, really fun to work with. And that's what you got to have. Writing a book is not it's just not pleasant. You got to go down into a rabbit hole and spend some time down there. And when your wife says, come up for dinner, and you're not ready to come up for dinner, you don't come up for dinner. And she gets mad at you,
Yeah.
and you've got everything laid out where it needs to be. And I don't care if the kid has a hockey game. I gotta get, it's a real labor. And you don't make a lot of money on it. But in this particular instance, it's so important that people understand that the soil food web is what makes life for us. And this is a part of the soil food web that needs to be part of it. In fact, I'm telling people now, start with teaming with microbes, then go to teaming with bacteria, then go with teaming with fungi, and then go to teaming with nutrients. Teaming with nutrients was written because I was sitting at a restaurant, I think it's called Beppi's to something or other. It's an Italian restaurant, chain restaurant. And there was a picture of 5 ladies eating bowls of spaghetti in front of me. And I kept saying to myself, how do plants get there? What happened? How do they get the food inside them? How does a plant eat? And I couldn't figure it out, and so I had to write a book about it. I mean, my God, I got to keep my eyes closed now.
So it's your literary poop loop, so to speak.
Yeah, exactly. So the thing is, and I've told 100 people so far, I'm not writing another one.
Yeah, we'll see if that lasts.
Yes.
Somebody then said to me, well, what if they discover viruses? Well, viruses are in soil, and they are important, and they definitely do stuff. And I had to cut off the bacteria at the phase stage. I just couldn't get into it. I mean, it was just one of those things, but it got me through COVID.
Okay. Yeah, there you go. All right. Teeming with Bacteria. Jeff Lowenfels is the author from Timber Press. Check his books out. You can find a link to it in today's show notes here on the Garden Basics. Debbie Flower had fun today.
I really did. Yeah, I've read Teeming with Microbes and Teeming with Bacteria, and I've got the other two, and I'm going to read them, Fungi and then Teeming with Nutrients.
There you go. Yeah, I mean, I learned so much from them. I mean, the point of these books is that, I'm not that smart. I had to dumb it down so I could understand it.
The amount of research you must have done, it boggles my mind.
Yeah, I do a lot of research, but I do it anyway. I mean, people should learn that Google is, or DuckDuckGo, or whatever we want to use, is your best gardening tool. Mm-hmm. And so, for example, you put in Lowenfels, once a week, my garden column's going to show up at your front door. You put in Rhizophagy, and whenever there's something new about Rhizophagy, you're going to get it. Mm-hmm.
But you have to know that what you're getting is from a reliable source.
Well, that's right. You've got to have some smarts, and you've got to learn, and that's something we're going to teach our kids, et cetera. But generally, with obscure kinds of science like this, it hopefully will not become obscure for a long time.
I'm a Rhizophagy punk. Yeah.
Yeah.
And by the way, thank you to the audience for sticking with us. If you made it through all of this, God bless you.
See, you can hardly shut me up.
Well, and you do one other thing. I'm sure you do lots of other things that are wonderful, but plant a row for the hungry?
Yes. Oh, yes. Yeah, and I'm not proud of the fact why it started, but I stiffed a guy at literally the coldest day Washington, D.C. has ever had. And I was staying at the Willard Hotel on an expense account. And I'd been there so many times that when I stood there next to Henry Kissinger, they came up and took my bags, not his.
Oh, my gosh.
I mean, it was one of those things. I mean, there wouldn't be two candies on your pillow. There would be a box of candies, and a bottle of wine and fruit. And I had my hand around money, and they have these signs that say, "Don't give money to homeless people. We take care of them. Do not give them money." And so I said no, and I went into a restaurant, and I had an expense account meal. Oh, my God. I did not sleep well that night. I did not sleep well when I went home. I was in first class, and I was having a steak and zucchini meal, and I thought, oh, my God, you terrible person. And I thought about the zucchini and the joke about in Sacramento, you never leave your car on the street with zucchini in it. Never. If your car is unlocked, I guess if your car is unlocked in Sacramento at night, you wake up the next morning, somebody's filled it up with their zucchini.
Oh, yeah.
Yeah, that's what it is. So anyway, I wrote a column because I had to write a column that night as well. And I asked my readers to help my conscience, and let's all donate one row in our gardens to a place called Beans Cafe, which is our food kitchen in Anchorage. Mm-hmm. And then the garden writers came up and adopted it as a national program, and it's still going on, and it's still important.
And it's spread.
So important, and it's so easy to do. And since you're the one growing the food, you're the one responsible for getting it to somebody that needs it, nothing slips from the lip to the cup in administrative costs or any of that kind of garbage. Mm-hmm. It's a wonderful program that can be adapted in so many ways. There's no ownership to it. It's just, go for it. Feed people.
That's wonderful. That's wonderful.
The old Garden Writers is now called Garden Communicators, Garden Com. And there's a page now, and in fact, the directory's there, so if you want to go talk to any of the people. And they have a Plant a Row deal. There it tells you how to become a Plant a Row person, and some ideas of things that you can be doing. So it's well worth doing. It's so easy. And with this Ukrainian problem and fertilizer problems, and just generally we have problems anyway with our hungry 35 million people at night.
Plant a row for the hungry. You can find it on the internet.
Yes, there you go. There.
Jeff Lowenfels, thank you for spending a lot of time with us talking about teaming with bacteria.
You're welcome, and thank you very much for doing that. And I hope Dr. James White becomes a little bit more famous, and Dr. Elaine Ingham does as well, because the soil and food web is all.
Mm-hmm. Yeah, it's a basis for life.